Hey Phil, how you doing? Welcome to the Built for Trust podcast.
Yeah, hey Nick, it's great to be here, and looking forward to the conversation.
Yeah, actually, me too. You're one of my favorite folks as we've been kind of working together over the last couple of months. At least as we've been kind of diving into how AI is impacting our industry. But before we get into all of that, for those folks who don't know you, like I've always been so impressed with like your career path and your journey. So could you share a little bit about that, and kind of how you got in the industry, the companies that you started, and what kind of brings you towards, your last transaction, which was the acquisition of Moogsoft by Dell. So why don't we
Sure.
start there? Okay.
Okay. Well, it's a very circuitous story. I
Yeah.
never set out to be. I think I sometimes get described as a serial entrepreneur, but I guess I've always really modelled my career on a book a million years old now by Bob Cringely called Accidental Empires.
Hmm.
It was all seemed like it made sense at the time, but in retrospect, we did a lot. Way back when, I was very intense on really going into pure science, into theoretical physics, and I
Hmm.
was, off, getting my PhD and all the rest of that kind of stuff. In fact, one of my claims to fame is, or claims to infamy, is I turned down Peter Higgs as my PhD supervisor, who knew he'd go on to be quite famous. Um,
Yeah. Wow.
but in any case, as with most people who set out to do that, it turns out that there are some downsides to that life. Not least of which being it's almost like a monastic living in the sense
Hmm.
of what you do. So I ended up coming into software because it kind of married the mathematical stuff with a sense of fun and play and discovery.
Hmm.
And having spent 3 or 4 years kind of cutting my teeth as a software engineer, and including some time in California, I came back and started building a software product to fix a problem that I was frustrated with
Hmm.
in network management, which was just how complicated it was to get set up to do event management. And that product went on to become Netcall Omnibus, and I co-founded Micromuse in the early 1990s. It was a spectacular run, went public on Nasdaq. I'm
Hmm.
sure the stories are all out there about the other guy, Chris Dawes, who's no longer with us.
Yeah.
But as that was coming to an end, I followed my curiosity again into looking at network topology discovery and root cause. That became a company called Riversoft that went public on the London Stock Exchange. And the sort of the whole history is just repeated startups. I did a software defined storage company called Engini that got acquired by Riverbed,
Yeah.
and then ended up in an incubator, which was intimately associated with turning the tender age of 40 and realizing that I had more ideas than lifetime left to pursue all of those passions. And so I did a kind of a company factory. And at the tail end of that, this was, in 2011, 2012, myself and my co-founder at Moogsoft were getting approached by a lot of our old friends who were
Hmm.
dealing with the virtualization, the software-defined data center, from network and storage all the way up to compute. And what they were saying to us was, if you want to monitor for availability, there really isn't a good solid tool that will deal with all of that change, because rules-based systems require you to know where everything is and kind
Yeah.
of sort of arrange things in that regard. So that's when we started experimenting with AI and ML in the context of event management. And that company factory that I talked about,
Hmm.
the team there was around AI. It's where I reconnected again with academia. It's where the silly title comes from because I finished my PhD and got a PhD in network science and informatics AI, if you like. And we built Moogsoft up from the ground up,
Yeah.
to address that. And we had a fantastic run. I mean,
Yeah.
AI was not a thing before Moogsoft started. We were there right at the outset of the coining of that term. I would say lay claim to Moog being really the founder of the AIOps movement and having really got the deepest AI approach to it. And of course, very recently last year, that caught the attention of Dell. They have their own ambitions in the AI space,
Hmm.
particularly in AI ops. They have a product of their own, Cloud IQ, and we sealed the knot on August the 12th of last year, and here I am as the erstwhile CEO of Moogsoft, and now a vice president inside of Dell's ISG organization, responsible
Yeah.
for all things AI ops and software.
Yeah, what a story. Really just an amazing journey so far, and they're so young. It's like, it's interesting too because I studied electrical engineering undergrad and systems engineering in grad work. During my undergrad work, I took a course in modern physics, and it was like, I don't know, it had to be like 150 or so students in it, and there was like only at the end of it, there was probably only about like less than 10, and I aced it. And so that gave me so much encouragement to like say, I think I want to explore, a degree in physics or maybe a minor in physics. So the next semester I take this other, course in physics. It's I don't know, maybe introduction to wave theory or something like that. And we started off with F equal MA, and then and the board was like full, with equations, Maxwell's equations that describe kind of light as kind of waves of electrical and magnetic fields. It was after that class I'm like, no, I really don't want to do this. This isn't really for me. It was like I was fascinated by the compactness of F
Mhm.
equal MA and how it all kind of like, gets, connected, through math. But I was like, no, I don't think, this is really kind of the right discipline for me. So I was kind of falsely, impressing myself, with acing a really difficult, course early on in my academic career. But anyway, so I digress. Sorry, I had to kind of like, you reminded me of that, and I haven't thought about that, in probably at least 30 years, or so. But I think it's like where your journey is, where it kind of reminds me of something like Doug Comer, said. It basically said is like, all science is computer science and all business is digital business. And,
Mhm.
and I think that kind of maps into what you were, your kind of your
Yeah.
journey a little bit, it's like you were frustrated with a problem, you needed to, wanted to solve it. And then that kind of like, guided you into kind of the world of
Yeah.
software. And, and there, you started opening up and starting up these various different companies. So that's, anyway, so that really, really great background, Phil. And so now you've always maintained a relationship with academia and
Yeah.
industry.
Right.
Why don't we talk a little bit about that? Because like a lot, not too many people do. It's like usually you
Yeah.
spend your 4 to 8 years, and then you're kind of off, and you become either you join kind of advisory boards or you support the endowments, what have you. But so yeah, why don't we explore that a little bit?
Yeah, I mean, there's an awful lot of that again is sort of follow your curiosity, and when we were kind of my journey back into more of an involvement with it really started when we did the incubator in the beginning of Moogsoft, because we were engaging quite a lot with the University of Sussex in the UK, where I graduated from originally, and they've got some very interesting academics. I remember going on a tour of the labs there, and this is a true story, but it's quite funny. There was a guy that was doing some research on biocomputing, and basically what they were doing is they were taking the brains out of snails and wiring them up and using them to do basic computing with.
Hmm.
And this is kind of fairly gruesome. It's kind of bad news for the snail. But the punchline,
Sure.
yeah, it is bad news for the snail. The punchline for the story is this guy was actually the great grandson of Mary Shelley. So how about that? It's kind of life imitating art or science imitating art. Um,
Yeah.
and so they had all this kind of really interesting stuff, and I kind of started finding myself. you know, getting curious again about the process of science and how it can, interlink with academia. Academia can interlink with business. Because if you think
Mm,
about it, I mean, the computer networking, call it what you will, the digital revolution. Um, the line is very porous between where the discoveries and the breakthroughs are made.
yeah.
If you're working, at DuPont, or in a pharmaceutical industry, the hardcore discoveries have been made in universities, whether they like it or not. And you spin people out, you spin departments out when there's of interest. In computing, it's a revolving door.
Yeah.
People go back and forth between the two. We all meet at conferences. We all talk. So, we started engaging in, not just hanging around universities, but doing some of the research. And, that started a very personal journey for me, actually, back into
Mm,
that. And I'm very passionate about how these things interlink. I ended up going all the way back into theoretical physics. I mean, I largely these days when I publish papers, not as often as I would like to, maybe 2 or 3 times a year. They tend to be in foundations of quantum field theory. And you
mm,
might think that is a million miles away from AI and networking. Actually, kind of isn't,
mm,
because really the connection point is graph theory, network science, which arises out of all the sorts of considerations that we have when we're trying to make a hyperscale infrastructure just not collapsing on the weight of its own complexity. And that's where that connected. So we do all kinds of things, did all kinds of things at Moogsoft. We sponsored PhD students. We had something called
huh,
a KTP. We have links with Oxford, Sussex, Queen Mary in the UK, Arizona State University, and through a collaboration with the University of California at San Francisco. I maintain a position at ASU as a extended faculty member and professor at the Beyond Centre, and also at Sussex via the Royal Society. Work with them as an entrepreneur in residence, which is not the VC meaning of that. What that really means
yeah,
is I turn up and help them, give them advice on how to craft curricula, how to mentor students into entrepreneurship. I teach an entrepreneurship class, all that kind of
mm,
fun stuff. Mentor an internal digital agency so kids can get a first-hand experience really of what it's like to start stuff. Because here's the deal: um,
mm,
the problems that we face in our industry are, all the easy stuff has been done.
yeah,
All of the easy stuff has been done. We are grappling with extremely complicated intersections of AI, scale, complexity, um, computer science, and maths. And we need the brilliance and the insights and the genius that comes out of academia. And frankly, they need our real world problems, and to a
yeah,
degree our money as well, to help support them.
yeah.
So we've always been passionate about that, continue to be passionate about it. And what's more, it's a lot of fun. It really is a lot of fun. I remember when my supervisor, when I was writing up, said to me, and I asked the question, "Am I ready to submit the thesis?" And I remember his words to me were, "Well, if you think you've had enough fun, go ahead and write up."
Yeah, I've sure
I don't know how
done.
you answer that.
Yeah, I don't know, it's almost like, "Hey, I've been really working hard on this," It wasn't that much fun, but it's like, I guess.
Yeah,
Well,
it's
that's
all
I
good
think
stuff.
yeah, I know, I think that is, like, really just so important, the it so there's a couple of thoughts that are kind of going through my head with this. First of all, is that there is a major shortage of both kind of network engineers, security engineers in our industry. Our industry also, we're aging. We started this industry, really back in like the kind of mid 1980s, time frame, and I'm not sure. I haven't seen a study on how many new people constantly are coming into our industry from a kind of protocol development and engineering kind of perspective, and not like the folks who actually manage kind of the products, once they're deployed, but actually kind of breakthroughs around new thinking around how networking and security could and should be done. The we used to have the IETF kind of had a role, of at least not just standardizing, but really just thinking through hard protocols, which are really nothing more, not nothing more, but they're mathematical models of particular, behavior that we want to model and codify, and so there was a lot of brain trust there, and it seems like that has kind of waned.
Yeah.
And I'm not sure like where the relationship between our industry and academia really is. Obviously California does a really great job, both Berkeley and also Stanford. I would really wish that in New England, where we, in essence, we have like almost like 4 or 5 Stanfords that are like, 5 miles or 20 miles away from each other, there would be a kind of an opportunity there. But there, I guess everyone's going after like other problems, bigger, potentially maybe bigger problems, or like the social networking, wave that hit, 10, 15 years ago. That was a large sucking sound, kind of like taking a lot of young
Yeah.
folks and bringing them there. And the financial services industry always does a really great job recruiting also. So anyway, I guess where I'm kind of going with all this is that it's not only admirable, for you to have that relationship, within academia and also within business, to kind of create that better liaison. Wish there was kind of something more that I think maybe everyone could do once we get a little bit further, like in our careers. So I think that's
Yeah.
no,
Nick, I think that phrase used there, the sucking sound of social
mm,
media. It is absolutely a truth that right now, if you were to call it, you'd say that Gen AI is occupying 4/5 of every conversation in the IT industry,
yeah,
and it's arguably, in a lot of ways, overrepresented. I mean, it is one aspect of artificial intelligence, or how I like to think about it, mathematically driven algorithmic computing, because machine learning and AI, as bedfellows, encompasses a lot of very different techniques, and there are many, many ways of solving the problem. And I think that in networking, the interesting thing in networking is there's a whole other class of information theory driven approaches, and AI driven approaches, which are of themselves very interesting academically. And I spent quite a bit
mm,
of time talking to folks in the computer science informatics world about the kinds of problems that we grapple with. Like, for example, packet by packet routing decisions to, optimize resilience, security, and performance.
mhm,
Typically that was done as a manual tuning exercise back in the day. There are algorithms that are out there now that will allow you to forward predict things like the demand matrix on a graph, or a network, which will allow the devices themselves to make intelligent decisions about where to route, data against some sort of objective function. So you start to think systemically about the whole network in a very different way. And I hold out the hope that the problems are sufficiently interesting that they
yeah,
will start to draw brilliant minds into looking at that. And as is always the case, and I'll probably get off my soapbox in a second, as is always the case, yeah, in all scientific disciplines, its intersectionality is where the action is at. So
mm,
there may be tens of thousands of people researching AI. It's the people on the fringes of that research that are also have got one foot in drug design, or one foot in I don't know, game theory, or one foot in network science, that will stumble across the thing that's going to change our world.
yeah. That makes a lot of sense. As we've, I'm going to start to shift a little bit in our conversation, and because I think once we started to work together, I really didn't understand how systemic the impact, that AI promises to make in our industry. And yeah, I totally agree with you. The whole chat GPI thing is kind of like dominating, a lot of conversations. But to me, that's really not that interesting. There's interesting attributes of that. But I think where we started to like go And like in our conversations with Andy, we're okay, well, let's think about how AI now starts to penetrate down into the protocol layers, of networking. And I know we focused on one particular part, and that was kind of the cost basis,
Yeah.
where you kind of run Dijkstra, and that kind of defines how you kind of move from a shortest path to get from one point to another point within a network, and then what is that cost? That is computed, and so can we now extend that definition of cost and have a security posture in there, have a real dollar cost, have a latency cost, and do all that on the behalf of the application? And so now it's really that, the network is not just providing kind of a connectivity service, and then there's a lot of folks that are kind of tweaking things behind the scenes, but really kind of what the network is really delivering is kind of an experience service on
Mm.
behalf of that application to make sure that that application gets the kind of service that it's been, maybe a policy has been defined to be able to deliver, for it, or has been able to kind of articulate, and what is the intent of that application, what is the intended experience for the user for that, and then the AI figures that out. That that kind of I have to say that kind of blew my mind to think of networking that way. I never thought of it, in those terms. I was thinking more around orchestration management, configuration
Mhm.
management, change management, and how AI could eliminate a lot of that toil that happens like day to day. And then, but we've kind of went into a very different and frankly a really exciting domain. Do you want to, kind of share
Yeah.
what your thinking, has been around that?
Yeah, and sort of in a sense, going backwards. I mean, it's categorically the case that one of the huge impacts of AI, whether it's pure generative AI or other variants of that, is of course going to be automation and the elimination of you know error-prone manual tasks in the operation of the thing which we call the network. So,
Hmm.
so definitely configuration management, change management, design, all of those kinds of things are definitely going to be impacted by it. But you're quite right. What people don't spend as much time thinking about is what happens when you push that intelligence all the way down to the device.
Mm.
And in particular, when you start to get the network of intelligences, if you like, talking to each other. So instead of the if you kind of think of the microcode on a networking device as really being a very atomic thing. I mean, it's got one job, and it sits there optimizing extremely linearly. It's one job, and
Yeah.
that one job might be pack it in on port A, pack it out on port B, and and we spend a lot of time making those autonomous devices very resilient, very powerful, very fast. And of course, back to the original starting point with AI, maybe we can make it easy to configure and set them up. But now imagine that those devices are talking to each other. And now imagine
Yeah.
that they're non-trivially intelligent. So they're able to, assess collective behavior with a collective mission. And that collective mission might be reduce my attack surface. That collective
Yeah.
mission might be, improve my resiliency. That collective mission might be a cost optimization one. Like it's very expensive to send data down this link, and cheaper down, another link. But depending upon the data I'm sending, maybe I want to spend the money for a
Yeah.
higher quality sort of backhaul or whatever it might be. So I think that is where there is a huge opportunity for AI to lean, and there are definitely people thinking about that, thinking about taking the AI to the edge to do it. Now, I mean, it's an aspirational position to think of that operating on a packet by packet basis, because again, there is a compute cost that comes with all higher sort of AI capabilities, high computational abilities, and not
Mhm.
all applications in the network are going to warrant that kind of level of cost. But I do think, particularly in the area of security, and particularly in the area of low latency networking applications, that's what I think we'll start to see the first of the adoptions of that kind of technology, where the consequences of getting it wrong either have an immediate dollar impact, or have an immediate catastrophic impact. Like,
Mm.
we live in a very dangerous world, and there are rumors about that China is hacking us continuously. Well, so far, you know who cares if it's your Netflix runs slow, but if it happens to be the network that's, for example, running our nuclear deterrent, I think we need to be worried about it.
Yeah, well, that's for sure. Yeah, and I think we can rest assured, not rest assured, but I think we know for sure that they are hacking us all the time, as well as Tehran and North Korea and
Yeah,
other kind of states.
100%.
Uh, but I think so. When I love your the concept of really kind of uh, focusing where we might see kind of the kind of short-term gains, and so that is around kind of security posture, security assessment, security mitigation, and then also around latency. Obviously, there's the whole cloud edge part of the
Yeah,
network where there's everyone's kind of rethinking how do we bring applications closer to either consumers or closer to users, and so and make those secure as that diameter gets expanded out. So that actually could be a really great area
yeah,
that we'll see
totally
this.
agree.
And I think the area that you focused on in your last company, which is now part of Dell, is also a really key area, right? Because that's really all around the operational aspects,
Yeah,
of running this infrastructure. And you said something at the last ONUG. It was we've been focusing around all these emitters and how different they all are and
yeah,
how our industry has never been able to converge on a standard set of emitters. Maybe MIBs might have been the closest thing we ever got to it. Maybe S-Flow might have been that as well. But if we think about an application and its dependency map and all of those devices, they all have different emitters. They have different schema. They have different formats. They have different definitions. And so anyway, so the question that was posed to you is that, how do you deal with that? And how do you get the data so that the AI algorithm, can actually make good choices, good decisions? And I think what you said is that we have to kind of understand what's the minimum amount of data that we need in order to have a high confidence of a decision. And I
that's
thought
right.
that was probably a realistic, way to look at that, right? Because you can't get 100% of the data in the format that you want because
Yeah,
certain companies don't own those emitters, and either you create these kind of adapters or modules that convert things into a standard kind of format, or you have broad industry acceptance, and so both the latter is probably or the former is probably the easier one. You have kind of a market for adapters. But anyway, I wanted to ask you if you can expand on that,
yeah,
and how do you see kind of the operations role? Because I'm I'm thinking that we have an opportunity in this cycle to start moving towards a lights out operational kind of model,
yeah,
aspirationally, right? So what were you
100%.
thinking when you said that?
So yeah, I guess human beings are very messy, Nick, and we've been around long enough to have seen many failed attempts at kind of standardize stuff and sort of rationalize industry wide how operationally networks and systems are managed. And you pointed out MIBs, and the latest fad is OTAL. And it always boils down to the same thing, which is building an ontology of the data, building a kind of a meaningful way of understanding what is it that it's trying to tell me. But I think it goes a lot further than that now. So if you let's take observability as a term
Hmm.
that gets bandied around in our industry. Um, and again, this is something that is usually conflated incorrectly with monitoring. People go observability and monitoring. They go,
Yeah.
here is my system that what it does is, it pings servers, or it reads NetFlow data, or whatever it might be doing. That's observability, and it kind of really isn't.
Yeah.
Um, Observability is a process. It's the process of rendering the thing that you are talking about observable. Uh, so, getting it to tell you when and only when you need to know something, and getting it to tell you in a way that is meaningful. But let's layer AI into this. So, you don't have to spend too long talking to people who do machine learning and AI for a living. And you'll
Mm.
soon get on to terminology around things like feature discovery. And so, what they'll say to you is stuff like the algorithms themselves. I mean, even, the glorious Chat GPT, is, in a sense, pretty simple. The algorithms are mathematical machines
Hmm.
for, optimizing, some cost function or some objective. But the how you present the data, whether it's the training set or the actual real data that you're trying to classify or understand, or whatever it might be, an awful lot of work goes into the feature engineering of that data, the preparation of the data for
Mm.
consumption by the engine. Sound familiar? That's kind of like
Yeah.
observability.
Mm.
And
Yeah.
it's
Mm.
when you start to think about, well, now, given the scale, given the complexity, given all this, that, and the other, we need to start to think about making my thing observable to an artificial intelligence. It puts another layer of burden and consideration when you are going through that process of not just sending junk in the hope that somebody at some point will make sense of it. It's a bit like when you think of how applications and infrastructure logs out. Some shipwrecked sailor not just putting one message in a bottle and throwing it into the ocean, but trillions of messages in a bottle in the hope that
Yep.
somebody's going to
Mm.
pick up the right one that says, "Here are my GPS coordinates. Please bring gin and tonic when you pick me up." And
I like that.
it's that kind of crazy thing that's going on. So I
Yeah.
think there's going to be an additional burden on both equipment manufacturers, professionals, people in the observability and management and monitoring space to really think again about what it means to send data out to a surveillance system, whether it be for availability or for security, whatever it means, and thinking about how you process that data forward. Because one thing's for certain, it doesn't matter how smart the algorithms are, rubbish in, rubbish out, rules all, and we have to be very cognizant of the rubbish.
Yeah. Yeah. That's really kind of fascinating. So I think the way that I'm kind of thinking of it is that we have all these emitters that are coming in. There's a lot of kind of scrubbing, formatting, maybe canonicalizing, kind of that data to a format that can be presentable and consumed by the AI engine, so that there's consistency there, and then that provides good data in so that we can have good data out. Is that
Yes.
kind of, yeah. Yeah, that makes a lot of sense. And so it's that canonicalizing, piece, that, is difficult, and how much of that, how much of all these emitters do you actually get to actually canonicalize or get into that format? Because I thought the way that I've always thought about observability was that you're kind of observing something, but you're not observing it directly. You're observing it indirectly through other kinds of metrics that tell you about, the thing that you're trying to observe.
Yep.
Almost like a little bit like the Heisenberg principle, right? It's like if you try to measure it, you're going to mess it up. And so it's like you have to kind of look at all these metrics around it to understand that system. And that, to me, that really was the difference between kind of observability and monitoring. Monitoring is that, okay, you have data and you're kind of like pinging that, and you're kind of constantly just seeing what the state of that particular entity is. And that makes observability much more interesting, because you're looking at behavior around that particular system, and that how you now come to conclusions, about its state, where you
Yeah.
don't have a lot of the data. So I think and you're right, that's a great use of AI, and a great use of kind of machine learning, as well. And So then how do you think that will evolve in that space?
Yeah.
We have obviously we have tools, like you spent a good chunk of, the last like decade or so, building a company that is like focused on this. Where do you kind of see
Yeah.
that part of the industry progressing?
So, I'd probably use an analogy from another bit of physics than Heisenberg's uncertainty principle, which is, to make a statement that in essence we're always battling entropy. Uh, and what do I mean by that? Well, entropy measures the difference between what you do and what you don't know about a system. So, as we're monitoring it for a given set of alerts, for a given collection of data that we've extracted from the system, how many states are consistent with the data that we know about it? And if you've got a high entropy system, there's a lot of uncertainty. There are many different things that can be going on that can produce the same set of data that you currently have in mind. And
Uh,
obviously,
mm,
high entropy is bad news because it means you are relatively unaware of what the state of your monitored system is, and you're at risk of being caught out by something not being quite right. And I think with one way of thinking about the AI revolution in regard to monitoring is for the same set of data, can we reduce the entropy of what we know about the system? Can we infer more about the state? And
mm,
that is both a receiver and a sender problem. So kind of back to this business of I'm gonna condition my monitored device to share a different set of data because it's going to contain more clues in a more efficient way about what my state is. And then on the receiver side, can I build smarter and smarter algorithms to narrow down where there is a problem
mm,
more precisely, given the same set of data as prior? And I think that's where without it sort of without me descending into a pitch, where I think the real advantage of Moogsoft was, we spent a lot of time thinking about that problem, and the approach that we ended up with, which was a really curious combination of multiple algorithms, multiple different ways of approaching it, really did do a very good job of narrowing down, where there was a service threatening outage of some sort or other in a given system. And it was a
mm,
gigantic entropy minimization task. And as any good student of physics will tell you, you can't violate the second law of thermodynamics. So to make entropy
mm.
go down, you're putting in a lot of work to
Yeah.
do that. And we did put in a lot of work to do that. So, but the work was all on us to get it
Yeah.
done.
That's interesting. That's good. I never thought of entropy in that way before. But that's okay. Yeah, that's another way to kind of okay reduce the entropy by increasing kind of the signal of the
Yeah.
observability of that particular system. That's okay. That's yeah, awesome. All right, so let's see. I want to maybe shift gears a little bit. There's like you, there's lots of folks who are now starting to think through, and I don't believe like everyone has really kind of thought through a lot of like how AI is going to impact like our industry. Um, just from I haven't seen any study, but I think it's really just from the various different touch points and conversations I've had. I think folks who are really in for kind of a big shock. If we're kind of right around how this is going to impact everything, like all this, and so so a couple of thoughts. One is that AI doesn't care about silos. So the whole silo concept about having silos in an organization, that's going to go away. And so that'll also beg for a very different kind of organization around how and how infrastructure is managed and how kind of the whole digital infrastructure of a company is managed. A lot of folks are concerned about, okay, well, will AI take my job? And I think what we're starting to understand is that it's not a job replacement thing, but what will replace your job is somebody with AI skills. So you really need to, start getting up to speed. Um, we're also starting to see, and so we're gonna. I want us to start thinking a little bit about kind of organizationally and how, we're going to start to think about how do we manage kind of the people and this infrastructure as AI starts to move more and more into it. But there's also another activity that's happening in some of the large public companies where the CEOs are actually starting to implement chief AI officers. And those chief AI officers, have kind of dual roles. They're kind of like, okay, well, it's almost like AI is this large efficiency engine, and look for places where you can apply it, where you're going to get a lot of efficiency, whether that's on the business side, and either kind of revenue generation or expense reduction, or it can also be on the kind of the IT side, on the things that have
Yeah.
been in place for a really long time. And so that sets up almost like an adversarial kind of role in some places. So I think the maybe the question out of all of that, is, you know, do you have any thinking or any thoughts around, how this might impact organization design, and also how we might actually organize IT within industries? Will IT go away?
Yeah.
Will that become like within the next 10 to 15 years? Will AI be something that was done basically for the last 50 years? Well, like in the next 50 years, there's a new model, on how we approach digital infrastructure and kind of how companies participate in the digital economy.
Yeah. I think the big difference is, in some ways, I think IT in business for many many years was a little bit like the drive-through window at a McDonald's restaurant. The
Hmm.
business would drive up and say, I'll take 6 SAP accounting systems and a bit of NetSuite and a global network, please. Fries with that? No, thank you. And you drive around to the window of IT, and there will be 6 SAP systems and so on and so forth. The
Yeah,
world in which we're in now with AI is much more like a culinary institute, where it's definitely a restaurant that you go to, but you both learn how to cook, you engage in the process yourself, and you get exposed to great ingredients, and you get fed. And you quite rightly point out this business of a chief AI officer. We've got one at Dell.
mm,
Uh, Very fine chap, Jeff Boudreau. And this is kind of really coordinating the activity across all of the IT and development functions, but then into the business. So,
yeah,
as you're thinking about everything from, back office automation, finance, HR, how we find our customers, how we transact with our customers, how we support them, how we, improve the products that we sell to them, how we engineer the products. It touches everything.
yeah,
And, you have to sort of, fully integrate in the computer science function of the business into the business. And, no longer think of it as, we're just here to help when somebody turns up and says, it'd be really nice if we could take credit cards in Namibia. Well, it's like, well,
mm,
who cares about that sort of transactional relationship anymore? It's about how you design your company to be optimizable from a P&L perspective, and it's going to have profound impacts. I
yeah,
think that I've got young children, and as every parent does, you try and think through, what is their journey going to be like. For me, it was so much simpler in a lot of ways, because there are real professions, and I mean real professions, that
yeah,
will likely not be there when they get to my stage in life. And what I mean about those real professionals, I saw a demo of a product not so long ago from a company called Orbi.ai. And in essence, it sits in a web browser and watches how you interact with documents and systems, learns what you do, and then automates it. So,
mm,
if you're a contract administrator, well, that puts you out of a job.
yeah,
And it doesn't take too much, time to think that, you could level that up to being a large part of the legal profession. Um, you know, Primary care as a physician. when you've got a human being in front of you saying things like, I'm coughing a lot, and I sweat when other people aren't sweating. I mean, there are a million and one ways back to the entropy thing that could be wrong with you. A computer will probably do a better job of being more comprehensive of that first stage diagnosis. And I know, in a sense, what I'm saying is old hat. I mean, I'm just articulating the fact that what we think of as very sophisticated knowledge work becomes very automatable when computers are not quite genuinely artificial intelligent, but certainly at least as smart as generative AI and beyond that. So I think that if you're somebody entering the workforce, planning your career, or already in the workforce, you need to have a long, hard look at what it is that you're doing and say, how do I become a better version of me?
Mm.
By automating away using AI the most mundane aspects of my job. And if, when I've sat down and I've thought about that, there's nothing left of my job, retrain.
Yeah. Yeah. That's I think we are just in for like such a transformational phase, and in a relatively short period of time, as well. So it's, I think, which actually makes me really, I'm not sure if happy is the right word, but more like I'm really pleased with the work that we're doing together, putting together the AI networking summit, because
Yeah,
at first we thought, okay, it was just going to be a track, okay, we're going to like, all right, there's going to be a couple more sessions here, but we're going to have these other tracks. And then I think as we started going through it, we realized every single topic, this has an impact. This isn't a track. And that's why we kind of like said, okay, it's not a track. This is actually what we're talking about, now. It's
yeah,
all about,
yeah,
in our industry, AI networking, and we're kind of bringing the security piece into that because it's really all about infrastructure, right? And
yeah,
so I think, and so that was the first kind of thing that clued me in on how systemic it really is going to be. And then it's been going, kind of, it's been expanding really ever since. So I think, hopefully we can play a role by providing at least a place where people can come and get educated, understand maybe what some of the tools are that they can use, how they can augment their careers, make sure that they become AI
yeah,
proficient, and or at least be exposed to places where they can get tools and techniques and best practices on how they can actually proceed within their company and also within their career. But boy, it's about to change, and it's about to change in a really quick, systemic kind of way. So
100%. And maybe just maybe. It's funny because I'm reading a book by Ian McEwan. I don't know if you know his literature, Machines Like Us, and it's quite fascinating because
mm,
it's a entirely fictionalized account of Alan Turing doesn't die. Transistors are invented in the 20s, and generative AI,
mm.
genuine AI, actually more than that with
Oh,
robotics is around.
yeah,
And we are inching towards a society, particularly in the rich parts of the world in which we live, where we may have to think about the order of society.
mm,
Where you remember we were all brought up with we're going to have loads of leisure time and flying cars and the paperless office and all the rest of that kind of stuff. Well, we
yeah,
might just be looking at that, where you tax the robots to pay for a general living wage for everybody because they're doing all the work.
yeah.
Maybe, just maybe, we're getting a sniff of it.
Yeah, it's like I do remember kind of like the quote about the paperless office, and the axiom was, well, I'll believe it as soon as there's a paperless bathroom, so so we're kind of like, so but I'm with you on the trend line, that we're going. I was a big fan of Star Trek and and not the Jeffersons, but I did like the Jeffersons too.
Flying
But
cars, yeah,
yeah,
absolutely.
it's flying cars, right? Well, Phil, I think that's probably a good place to kind of end it. This was really fascinating. It was a great chat. I got to know you better and a little bit more during this time, as well. So,
Yeah, great.
so I want to just thank you so much for not only just coming out to the podcast, but like all the work that you're doing with myself and Andy and the ONUG team on the AI networking summit. And so I know it's going to be a great program. It's it's so kind of exciting, and I'm so jazzed by the work that we're doing there. So thank you for being a big part of that.
It's a real pleasure. Thank you, Nick.
Excellent. Great. Thanks.